Good day. We're going to discuss about infinite limits. Before we deal with problems about infinite limits, let's discuss first about the function f of x, which is equal to 1 over x. And if we're going to look at the figure or the graph, now we have two parts of the graph here, which is the left-hand side of this vertical line, okay, vertical broken line, and the other side of the broken line. So let's discuss this, the graph on the left-hand side of the vertical line. So we have here, if we're going to examine, now as x approaches 0, okay, as the value of x approaches 0 from the left, okay, we could see that the graph of f of x is decreasing without bound, which means that the value of x is decreasing, okay, without bound as the value of x approaches 0. And we can write that in this notation. So that's the limit of fx as x approaches 0 from the left is equal to negative infinity. Why negative infinity? Because the graph is moving downward without bound. Okay? So if we're going to uh, substitute all the values of x which are close to 0 from the left, okay? Now the value of the function f of x is going down and down and down without bound, all right? Now, how about on the other side? On the other side, as the value of x approaches 0 from the right, okay? So as the value of x decreases and approaching 0, the value of the function f of x is increasing without bound, all right? So which means that the limit of the function f as x approaches 0 from the right is is positive infinity. So if we're going to write that, it becomes the limit of f of x as x approaches 0 from the right is equal to positive infinity. Now this is the graph of f of x, but the two parts of the graph have different behavior. Okay, so this one on the left hand side of the vertical line, x is equal to 0, it decreases without bound, okay? And on the right side of the vertical line, x equals 0, it increases without bound. So the limit of f of x as x approaches as x approaches 0 from the left is equal to negative infinity, while the limit of f of x as x approaches 0 from the right is positive infinity. That's why we could conclude that the the limit the limit of f of x as x approaches 0 is it doesn't exist. Why? Because the limit of on both sides are not equal, and at the same time their limits are infinity. Okay, and we knew that the limit exists when there is a unique, okay, or equal value of limit, which is a real number, okay, for the two sides from the left and from the right, for us to conclude that the limit of that function as x approaches to a certain number exists, right? Okay, so let's move on to the next graph. So here, let's talk about the function f of x, which is equal to 1 over x minus 1. And we can also draw a vertical line here, which is equal to x equals 1, okay? And the graph again is divided into two parts. Now, if we're going to consider the values of x on the left side of 1, okay, as x approaches 1 from the left, now the graph is approaching, or the graph is decreasing without bound. So it decreases without bound as x approaches 1 from the left. So we could write it in this manner: the limit of f of x as x approaches 1 from the left is equal to negative infinity. And on the other hand, as x approaches 1 from the right, okay, from the right, because it comes from the right, now the function value increases without bound, which means that the limit of f of x as x approaches 1 from the right is positive infinity. Or we can also write infinity, which means positive. Okay? So which means that we can conclude that the limit of f of x as x approaches 1 is DNE, or it doesn't exist. Why it doesn't exist? Because the limit on both sides are not equal, and at the same time, they're both infinity. Okay, which means we cannot identify the real number that this function will try to approach to, or the function value will approach to. Okay, so therefore, it doesn't exist. Okay, so the limit at its infinity can easily be identified or determined if we have graphs of the function. Okay, so let's define this situation. Okay, let f of x be a function defined on both sides of c. All right, except possibly at c itself. Then the equality limit of f of x as x approaches c is equal to infinity, or positive infinity, means the value of f of x increases without bound when x is taken to be sufficiently close to c but not equal to c. So that's what we discussed in the two examples a while ago. And let's have the theorem number 1. Okay, so here, let limit of f of x as x approaches c is equal to k, where k is an element of real numbers. So which means the limit exists in f of x. So let's write it down here. So the limit of f of x as x approaches c is equal to k, where k is a real number. All right? And in number 1, it says here, if k is positive, k is an element of positive real number. All right? Now, if the limit of g of x approaches 0, okay, which means all of the values of the function g as x approaches c are all close to 0, okay, which are positive values. Then the limit of f of x over g of x as x approaches c is equal to positive infinity. So which means that we could write it down here like this. G of x as x approaches c. Since we can distribute the limit to numerator and denominator, since the limit exists, then we could say that f of x is equal to k, wherein k is positive. Let's denote this as positive value. All right, and the limit of g of x is 0, but all of the values are positive approaching 0, okay? And which means that since both are positive, then we could say that the limit of f of x over g of x as x approaches c is equal to positive infinity. All right, now let's move on to the next statement. So how about if, okay, so let me just write it down here. Limit of f of x over g of x as x approaches c. What if f of x still positive, okay, a real number, and g of x, the limit of g of x approaches 0, but all of the values before it approaches 0 are negatives, okay? So which means this is positive, this is negative, so positive divided by negative are all negative, and it is infinite still, okay? It's just like undefined, but we cannot find the specific value or a real number that this graph will try to approach to, okay, the f of x over g of x, since the denominator is approaching 0, okay? So we have a negative infinity limit, all right? Now in number 2, if k is negative, okay, if k is negative and g of x approaches 0, where all of the values before approaching 0 are positive. So let's write it down here. So the limit of f of x over g of x as x approaches c is equal to, okay, again, the limit k here is negative. So k is negative, all right? And again, this is our notation for negative values of k. And the limit for g of x is 0. It approaches 0, but the values are coming from the right. All are positive, okay? So which means negative divided by positive is negative. So therefore, its limit is negative infinity. Okay, I hope it's understood. And on the second part, now, okay, I'm going to use the same notation. So if k is negative, while the limit of g of x is 0, approaching 0 again, and all of the values before approaching 0 are negative, so this would be positive infinity, since negative divided by negative is positive. Okay, so these are the theorem parts of theorem number 1, and we will be using this to solve for the limits of the given problem. Okay, so let's apply the definition and theorem number 1 to solve letter A. All right, so here, the limit of x over x squared minus 9 as x approaches 3 from the right. So the first thing that we need to do here is to try to factor out the given expression in the denominator. So that's x plus 3, x minus 3, as x approaches 3 from the right. Okay, so when we say as x approaches 3 from the right, we are considering values of x which are greater than 3 but close to 3. Example of that is 3.00001, 3.001, 3.01, and so on and so forth. So if x is approaching 3, okay, from the right, therefore x here becomes 3, and here becomes 6, right? And here, since x here is greater than 3, therefore a number greater than 3 but close to 3 minus 3 is close to 0. And the result is positive because let's consider 3.001 minus 3. This is equal to 0.001, and that is a positive value. So therefore, we're getting positive values in this factor, so x minus 3. All right. Now, since this one is positive, so therefore positive divided by positive, that's positive. And since it's 0, it becomes undefined, which means infinity, and with a positive sign. Okay? So that's how we get the limit of a certain function. Also, if we're not going to factor this out, we can also solve this way. Okay, so we have, if x approaches 3 from the right, therefore this is 3. And again, our x here are the values of x which are close to 3 but greater than 3. So if we have a value of x which is greater than 3 but close to 3, once we square that number, it is more than 9, right? So a number more than 9 but close to 9 minus 9 is approaching 0 with a positive sign. So therefore, 3 divided by 0 is infinity, that's undefined, and with a positive values, okay, positive possible values, so therefore it's positive infinity. So we have the same answer. All right, so whichever method you use, you can do so and you will get the same answer. Okay, and I hope we got the same answer or explanation. So let's solve letter B, and you may pause the video and try to solve it on your own. And once you have the answer, you can play the video and let's check if we have the same answer, all right, or equal answer. Okay, so the limit of x over x squared minus 9 as x approaches 3 from the right, from the left. Okay, so which means we are considering all the values of x which are less than 3 but close to 3, like 2.999, 2.998, 2.9, 2.98, and so on. Okay, so here, on the numerator, all the values of x will be approaching 3, right? And here, we could use the method that we applied here on the second, the method 2 in letter A. So again, all the numbers that we are considering here are numbers which are less than 3 but close to 3. So example 2.99. Since it's less than 3, therefore the square of that is less than 9 because the square of 3 is 9, right? So therefore, the values in x squared are numbers which are close to 9 but less than 9. So a number which is less than 9 but not less than 9 but close to 9 minus 9 is almost or approaching 0, right? It approaches 0. But what kind of values? Those values are all negatives. Why? Because these are less than 9. Okay, so less than 9 minus 9, that's a negative value, right? But we're trying to get here the trend or the behavior of the function, okay, on the denominator as the value of that function and the denominator approaches 2. So 3 over 0, that's infinity, that's undefined. And since it's negative, this is positive, this is negative, so therefore it's negative. All right, so the value or the limit of x over x squared minus 9 as x approaches 3 from the left is negative. Okay, so this is our answer, and I hope you get the same answer. Okay, now let's move on to the next. Okay, so here the limit x squared minus 1 all over 1 plus 2x as x approaches negative 1 from the left. So let's try solving this by factoring. Okay, so we could have x plus 1, x minus 1 over 1 plus 2x as x approaches negative 1/2 from the left. Okay, again, since it's from the left, we're going to consider all the values of x which are lesser than negative 1/2. Okay, so that's negative 0.5, so it would be negative 0.05001, negative 0.6, something like that, or negative 0.59999, something like that. Okay, so here let's substitute. Since let's assume that x is close to negative 1/2, or actually we are getting values which are closer than 1/2, closer to 1/2 but less than 1/2, negative 1/2. Sorry, that's negative 1/2. So if x is equal to negative 1/2, so negative 1/2 plus 1 is 1/2, positive, right? And if x is close to negative 1/2, negative 1/2 minus 1, that's negative 3/2 over 1 plus, if x is close to negative 1/2 from the left, therefore 2 times negative 1/2, and some of the values here are less than negative 1/2. Okay, so this becomes what's the product? Negative 3/4 over 1 plus. Okay, what's the value of this? This is negative 1, and since this is less than negative 1/2, therefore all of the values here are negatives. Okay, negatives. Now the question is it more than negative 1 or less than negative 1? So the value here becomes less than negative 1. Okay, which means negative 1.0001, something like that. Okay, so we have, okay, let me just write that here. So that's negative 3/4 over 1 plus negative 1 from the left. Okay, from the left, which means that we have negative 1.001, negative 1.002, and negative 1.005, which means that the absolute value of this is always greater than 1, which means once we subtract them, we will still get a certain value, a very small value, but negatives with negative signs. So therefore, they're close to 0 with negative signs. So here, negative 3/4 divided by 0, that's infinity. Negative divided by, sorry, 3/4 divided by 0, that's infinity, that's undefined. And negative divided by negative, that's positive. That's why our answer here is positive infinity. Okay? Or we could also do that here, this way, direct substitution. Negative 1/2 raised to 2, that's what? 1/4 minus 1, that's negative, okay, 3/4, right? Because 1/4 is less than 1/2. Okay, or less than 1, sorry. Or 1/4 minus 1, and negative 1 is greater than, is lesser than 1/2. Okay, and here 1 plus all the numbers which are less than, okay, less than negative 1/2. So these are numbers which are negative in values, and the absolute value of that is more than 1. So therefore, we will get a negative 3/4 over, these are all negatives, but the values are getting close to 0. So we have negative 3/4 over 0, that's undefined, which is infinity, and negative divided by negative, it's positive. So we will have the same answer. Okay? Okay, so the limit of this function as x approaches negative 1/2 from the left is positive infinity. So this is our final answer. All right. Now let's answer this limit as well when x is negative 1/2 from the right. Okay. So again, what we need to do is to factor out x plus 1. So as we could easily identify the behavior of the graph per, or the function per factor. Okay, 1 plus 2x as x approaches negative 1/2 from the right. Okay, here we go. So let's substitute. If x is equal to negative 1/2, this is 1/2 times negative 1/2 minus 1, that's negative 3/2 over 1 plus 2 times. Again, the values of x here are more than negative 1/2. So it's just like negative 0.5. So if it's more than negative 0.5, that's 0.4999, 4998, something like that. So which means that negative 1/2, okay? So let's simplify that first. Negative 3/4 over 1 plus negative 1. Okay? However, the 1 here are, or the possible values of this are negative values which are lesser than, sorry, greater than negative 1. Okay? Greater than negative 1, so it could be 0, sorry, negative 0.999 or negative 0.998, something like that. So these are positive values. Not actually positive values. Negative 1 or values approaching negative 1 from the right. Okay? So if we're going to simplify this, negative 3/4 over, this one is approaching 0, but we are getting positive values, okay? Because 1 plus all the values here, which are greater than negative 1, okay, like 0.9999 or 998. So 1 plus those numbers is equal or approaching to 0. And all of the values are getting positive, all right? Because the numbers here, the absolute value of the numbers here are all less than 1. Okay, so once we subtract that, it becomes 0.001 with positive sign, okay? So since 3/4 divided by 0 is infinite or undefined, then Negative divided by positive, that's negative. So therefore, our answer here is negative infinity. Okay? Now look at this, guys. The functions that we're trying to get the limit when x approaches -2 are equal. Okay? And also, they have different values of the limit. Okay? The limits are of different values. Uh, Actually, they're not values anymore. They're undefined. So it means that the limit of this, okay, the limit of x squared minus 1 over 1 plus 2x as x approaches -1/2 is equal to NDE, or does not exist. All right? So it doesn't exist. Why? Because they're not equal in the first place, and the other reason is they're not real numbers. And based on the definition, the limit exists if and only if the limit on the left-hand side and the limit on the right-hand side are equal, and the limits are, or the limit is a real number. Since infinity is not a real number, therefore the limit does not exist. Okay? Now let's consider this. The limit 1 minus x squared all over the fourth root of 2 minus x. So for us to get the limit, we need to consider the one-sided limits, right? So that's 1 minus, or let's factor out, 1 minus x times 1 plus x over the fourth power of 2 minus x as x approaches 2 from the left. Okay. And the other side is from the right. Later, I'm going to write it down. So let's simplify, or let's answer this one first. So when x approaches 2 from the left, which means the values here are less than 2, but close to 2. So on the numerator, let's substitute 1 minus 2. Okay, so that's -1. Correct? And 1 plus 2, that's 3. Here we go. And the denominator, 2 minus x. Again, the values of x here are less than 2, but close to 2. So which means these are like 1.999, 1.998, which means they are less than 2. So 2 minus less than 2, of course, it's always equal to a positive value. And the values are approaching 0, right? But with positive values or positive signs. So which means that we have negative here over positive, that's negative. Since the denominator is 0, which means it is infinite or undefined with a negative sign. So that's negative infinity. Okay? Now let's consider the other side, the one-sided limit, the right-hand side. Okay, so the limit of 1 minus x, let me factor it now. 1 plus x over 2 minus x raised to 4 as x approaches 2 from the right. Okay, so let's substitute. 1 minus 2, that's -1. And 2 plus 1 is 3 over. And here, the values of x that we're going to use are more than 2, but close to 2, like 2.001. So which means that 2 minus all these numbers which are greater than 2 but close to 2, the answers are close to 0, but with negative signs, since x is greater than 2 but close to 2, and raised to 4. So that's -3 over 0 positive, right? This becomes positive because of the raised to 4. And this is equivalent to infinity or undefined. Negative divided by positive, that's negative. So we have the answers, the limits on both sides of the limits are negative. That's why the answer here is negative infinity. Okay. However, since infinity or negative infinity doesn't represent a real number. Therefore, the limit of this function does not exist still. However, we can say that it's negative infinity for the sake of representation or representing the nature of the limit of this function. Okay, and we will be using the infinity as a form of limit of a certain function to describe the behavior of the graph. Okay, and however, again, the limit still does not exist. Okay, so how do we verify if our answer is really negative infinity? Correct. So let's use the specific given like x approaches 2. So the limit of 1 minus x times 1 plus x as x, sorry, 2 minus x raised to 4 as x approaches 2. So let's do direct substitution. Again, the values of x that we're going to consider here are, okay, values which are close to 2. Okay, it's either less than or greater than 2. So here, the numerator, 1 minus 2, that's negative 1. And 1 plus 2 is 3. And 2 minus x. So 2 minus x, x values are either less than or greater than 2, but close to 2, okay? So this could be 0, and it could be negative or positive, right? Since it could be negative when, negative values when x is greater than 2 but close to 2, and positive when x values are less than 2 but close to 2. So negative 1 times 3 is negative 3. And since this the denominator is raised to 4, therefore, whatever signs we have here will still give us positive values. So that's 0, positive. And 3 divided by 0, that's undefined or negative, sorry, it's or infinity. And negative divided by positive is negative. So we got the same answer, negative infinity. All right, I hope I already explained it as clear as I can, and I hope everything is clear. All right, so I hope you got the same answer. Okay, so let's deal with the, I think this is the second to the last problem. So the limit of 2x over 3 plus x minus 5 times 7 over x minus 3 as x approaches 3 from the left. So let's try using the property of limit. Let's take the limit term by term, okay, in a given function. So we have, again, all the values of x that we're going to consider here are less than 3, since it's from the left of 3 but close to 3. So like 2.99, 2.98, or 2.9999, and so on and so forth. So, however, these numbers are getting close to 3, okay? So we're going to use 3 here. 3 plus 3 minus 5 times 7 over, okay, and here, 3 minus 3. All the numbers or values from the left of 3 minus 3. Now, I wrote negative 3 from the left here since the denominator here would result to 0, all right? So let's simplify this. I have here 2 plus negative 2, 7 over, okay. Again, this is 3 from the left. And the values that we're going to consider here are values which are less than 3, but close to 3. Since 2.99 and other numbers, okay, which are less than 3 minus 3 results to a number close to 0 with negative sign. So we have 7 over 0, all values close to 0 from the left, okay? Or all the values which are negative and close to 0. Okay, so this becomes 2 plus negative 2 times 7, it's negative 14 over 0 from the left. okay? Or all the values of which all of the values which are close to 0 from the end from the left of 0. So this becomes 2 plus 14 divided by 0 is infinite or undefined. Negative divided by negative is positive. So we have positive infinity. So 2 plus positive infinity is equal to infinity. Okay? Okay, so our answer here is positive infinity. Or we could just write that this manner, or we can put plus, okay, on the infinity symbol to emphasize that it's plus, all right? But it's okay even if you don't put plus sign on the infinity. Okay, so the answer here is positive infinity. And let's consider this. And again, if you want to answer, just pause the video and you can solve it on your own. And once you're done, you can click or play the video to check your answer. I hope you will get the same answer. So the limit of negative 1 over 1 minus x squared plus 2x cubed over x plus 1. Now let's try applying the property of the limit, okay? We can take the limit term by term. So we have the limit negative 1 over 1 minus x squared as x approaches negative 1 from the right, plus the limit of 2x cubed over x plus 1. Here we go. As x approaches negative 1 from the right. Okay, so let's take the limit or solve for the limit term by term. So the limit of negative 1 is negative 1, of course, because the limit of a constant is always the constant. And here, this becomes, let's take the, let's factorize first the denominator, all right? Before we take the limit, so as we can easily identify the one-sided limits. Okay, so let's factorize the denominator. The limit of negative 1 over 1 plus x times 1 minus x as x approaches negative 1 from the right, plus the limit of 2x cubed over x plus 1 as x approaches negative 1 from the right. Okay, here we go. So let's take the limit. So then the limit of a constant is constant, which is negative 1. And here, we're going to consider all of the values of x which are greater than negative 1 but close to negative 1. Examples are negative 0.999, okay, or negative 0.998, something like that. All right? Okay, so we're going to consider negative 1 here. Now, as we substitute all the values of x here, the value for this factor approaches 0. But since x values are less than or greater than negative 1, such as negative 0.999, okay, wherein the absolute value of the values of x here are less than 1, therefore we're going to get a positive values here, but the values are approaching 0. Okay, and here 1 minus negative 1, it's 2, right? So that's 1 minus negative 1, that's 2. Plus here, that's negative 1, 2 times negative 1 cubed over here again. So if x approaches negative 1 from the right, the values of x here are greater than negative 1 and close to negative 1. So like negative 0.999, and which are the absolute value of x is less than 1. So therefore, the values are approaching 0 with positive sign. Okay, so let's try that here. Simplify. So negative, this is 0. So negative 1 over 0, positive, plus negative 2 over 0, positive. Okay, so this is 1 divided by 0, that's negative infinity. Sorry, 1 over 0 is infinity or undefined. Negative divided by positive, that's negative. All right. And here, plus 2 divided by 0, that's undefined or negative infinity. Again, infinity is not a number. It's just a sign that we are having infinity, or we don't have a specific value for the division, okay? For the quotient of this number. So it's just a symbol, not a value. And negative divided by positive, that's negative. So we have two negative infinities, okay? And 2 times infinity is infinity. So that's negative infinity. That's why our answer is negative infinity for this limit, okay? So we already found the answer, and I hope we got the same answer, negative infinity. Again, the limit of this function is, the one-sided limit of this function is negative infinity. All right? Okay, and let's move on to the last example. So the problem is the limit of 1 over x squared minus 3x plus 2 minus x minus 1 all over x minus 2 as x approaches 2 from the right. Oh, this is second to the last, I mean, sorry. Okay, so let's try solving this using applying the property of limit. Okay, we can take the limit term by term. So we can have the limit of 1 over, we can factorize the denominator, x minus 2, x minus 1 as x approaches 2 from the right, minus from the right, minus the limit of x minus 1 over x minus 2 as x approaches 2 from the right. Okay, let's simplify this. We have, okay, since we are considering all of the values of x which are close to 2 and greater than 2, it's like 2.001, something like that. So the limit of a constant is constant. And here, the values of this factor are approaching 0, all right? But the values are all positive, okay? Since x is greater than 2. So x approaches 2 from the right. And here, 2 minus 1 is 1, minus, here, 2 minus 1 is 1, and 2 minus 2 is 0. But all of the values here are greater than 0, but close to 0. So this is positive as well. So this becomes 1 divided by 0, that's undefined or infinity, and positive divided by positive is positive, minus 1 divided by 0 is infinity, and positive divided by positive is positive. So we have positive infinity minus positive infinity. However, positive infinity minus positive infinity is not actually 0. We cannot identify because infinity are not numbers. They're not values. They're just symbols, okay? Symbols for a known value. Symbols for numbers which are uh, values that are increasing or decreasing without bound, depending on the sign. But in this case, we have values, increasing values without bound and increasing values without bound. So we cannot determine their value. I mean, the difference of these two infinity, okay, symbols. So if this is the case, all right, again, if this is the case, now let's try to simplify the function first and then take the limit after we simplify, okay? So I will consider the function first, so that's 1 over x minus 1 times x minus 2 minus x minus 1 over x minus 2, okay? So let's subtract the 2. We have 1 minus x minus 1 times x minus 1 all over x minus 1 times x minus 2. Okay, and let's simplify again. So 1 minus x squared plus 2x plus or minus 1 all over x minus 1, x minus 2. Again, we're simplifying the, okay, the function here, right? Ito, this one. Okay, we're not yet dealing with the limits, okay? The limit of the function. So let's simplify this again. We have, I can cancel this out. So this becomes, I can factor out negative x. So negative x, x minus 2 over x, oops. Okay, wait a minute. X minus 1 times x minus 2. Okay, I can cancel out x minus 2 here, and this becomes negative x over x minus 1. There we go. So we already simplified the function, and it becomes negative x over x minus 1. So we're going to find the limit of this. The limit of x over x minus 1, or this is negative, as x approaches 2 from the right. Okay. All right, so let me just erase some parts. Okay, so let me rewrite the expression. Oh, sorry. Let me change the color of the pen. Pen color, yellow. Here we go. So let me write, oops. Let me change the color again, yellow. Here we go. So the limit of negative x over x minus 1 as x approaches 2 from the right. So here, we can substitute 2 to the values of x, right? So that's negative 2 over 2 minus 1 is equal to negative 2 over 1 equals negative 2. So the limit of this function is equal to negative 2. So we got the answer. Again, since we found we found a while ago that negative infinity minus infinity, okay, we arrived on this expression, then we can try simplifying the function to get its limit, okay? So our final answer is negative 2. Okay, and I hope we got the same answer. And this is the last example. We have the limit of 1 over x minus 1 times x over x plus 1 minus 2x over 3x plus 1 as x approaches 1 from the left. Okay, so let's simplify this. Sorry, let's take the limit first, all right? Using the property of limit. So we have the limit of 1 over x minus 1 as x approaches 1 from the left, okay, times the limit of x over x plus 1 as x approaches 1 from the left minus the limit of 2x over 3x plus 1 as x approaches 1 from the left. Close. Okay, so let's take the limit or the limits by factors and by terms. So here, the limit of a constant is constant, so this is 1. And again, we're taking all the values of x which are close to 1 and less than negative 1. So that's 0.999 or 0.998. So since x is already less than 1, therefore, the values here are approaching 0, but with negative signs because x are less than 1, okay? Times, okay, the limit of x as x approaches 1, so that's 1. And here, that's 2, all right? Okay, and the limit of 2x as x approaches 1, so that's 2. And here, that's 1, that's 4. So we have the 1 over 0 that's undefined or infinity, and it's negative because it's negative here, times 1/2 minus 1/2 is 0. And here, negative infinity times 0 is not actually 0 because uh, we really don't know the value of infinity here. And infinity is not a value, right? It's just a symbol for a certain part of the function value in relation to the limit. So if we got this expression, okay, once we take the limits of the terms or factors of the given function, then let's try again to simplify the given function, okay? Let's see if we'll get something, all right? So let's try, okay. Let's try solving that here. So let's try solving the function first. So 1 over x minus 1, all right, and times x over x plus 1 minus 2x over 3x plus 1. Okay, so let's simplify this first. So 1 over x minus 1 times, let's get the LCD, that's x. Okay, let's multiply 3x squared plus x minus 2x squared minus 2x all over x plus 1, 3x plus 1. Okay, here we go. So let's review 3x squared, 3 times 1, x times 1, 3, 2x squared minus 2x. Here we go. So let's simplify again. X minus 1. And let's simplify this. 3x squared minus 2x squared, that's x squared. X minus 2x, that's negative x over x plus 1, 3x plus 1. Close. All right, and let's simplify. 1 over x minus 1, close. And I can factor out the numerator, x minus 1 over x plus 1 and 3x plus 1. There we go. So I can factor out, or I can simplify. I think we can simplify some factors. I can simplify x minus 1 here. Okay, here we go. And we have what remained is x over x plus 1 times 3x plus 1. Here we go. Okay, and let's now take the limit since we already simplified. So the limit of x over x plus 1 times 3x plus 1 as x approaches to which value as x approaches to? It's 1 from the left, okay? Again, 1 from the left. So we're going to consider all the values of x which are close to 1 but less than 1. So therefore, this is equal to 1, this is equal to 2, and this is equal to 4. Right? So this becomes 2, 4, okay, 1 over 8. So the value, okay, the limit. So we found certain value of the limit of the given function. So the limit of this function as x approaches 1 from the left is equal to 1 over 8. Okay? So we found already the limit of the given function. And I hope we got the same value. All right? And I think this is the last example we have. And I hope you've learned a lot. And if you have some questions, just post your comment below this video. Thank you.